so long, we decided to divide it up into thirds, 3 parts. So today will be part 2. Part 2. So just like yesterday, when you did such lovely sitting and listening and watching, can you do the same thing today?
Yeah.
Okay, hoping we sit on our bumps so we're in control of our body. Okay, before we start the second third of the great lesson, can you tell me what you remember from yesterday? What do you remember from the story you heard yesterday? Yes, Ivy. Okay, Lucas, what do you remember?
That it was darker than a bathroom with no lights and no windows. Something like that.
What else, Jolene?
It was colder than a freezer.
It's colder than a freezer, darker than a bathroom with no windows with the lights off. And Alexi, what else?
I remember when the thing exploded.
The mass, the singularity, and what was inside that single mass that floated in space for all that time? What was inside it? Yes, Marco?
Particles.
Particles, you're right. And what was important about those particles? What would those particles do once the mass exploded with such power? What would they do? Evelyn?
They'll gather together
Yeah, they'll gather together
and make stars.
and make stars. Excellent. And Jolene, yes?
Never mind, I forgot.
Okay. Quinn?
They will form a great alliance to make the world.
Oh my goodness. That was such a poetic and beautiful way to say it. So those particles that shot out into space, expanding from the great explosion, as they cooled, remember, they eventually came together and they started making stars and planets. And actually, they are the building blocks of everything in the world and the universe. They're the building blocks of you. You're made out of those particles, right? You're actually made out of stardust. So, do we remember that those particles followed laws just like we do in our houses and our schools and our countries? Like rules, right? Do you remember the rule that we talked about yesterday that the particles follow? Yes, Marley.
Yesterday, I was interested about how the Earth was made. So I went on my mom's computer and I searched, what is the Earth made of? And it came up with nothing.
Marley, I'm glad that your curiosity was piqued by the first grade lesson. And we certainly know that the Earth is made of something. In fact, it's made of particles in the form of, what were the 3 states of matter we talked about? Lucas.
Gold, stone, and something.
Solids.
Gas.
Sophia. Gas, yeah. And Libby?
Solid, gas, and liquid.
And liquid, right. The Earth is made from particles, it's made from matter, and Marley, I think we're gonna have to do that search over again because there's certainly plenty of information out there about what the Earth is made of.
Yeah, but we don't know if that's the only thing that it's made of.
Well, let's do some research, and we also have a Layers of the Earth piece of work and puzzle on our shelf, so we can explore that later. So, what was the law called of the universe that made some particles want to come together really tightly to form a solid? Some particles want to come together, but not quite as tightly, and sort of roll over each other and take on the shape of any container or crack or crevice they entered. Or made some particles want to spread far apart and continue to spread. Do we remember what that law was called? Lucas?
Law of attraction.
Oh, the law of attraction. Did you guys all hear that? Because you must have been listening so carefully. Okay, so let's pick up where we left off yesterday with our story. So yesterday we learned that all the particles in the universe follow certain laws, which lead them to become solids, liquids, or gases. Who knows what this is?
A rock.
It is a rock. So what state of matter is this rock in? Ow! Mac, what is it?
It's a solid.
It's a solid. So solids are made from particles that are very attracted to each other. Remember that word? Attraction. And they cling to one another really tightly like this rock. And they have a definite shape and form. Would it be easy to break this rock?
No.
Oh, absolutely not. What is this? Marley,
Liquid.
liquid, that's right. So this milk I'm going to use for my cereal later is liquid. Liquid particles cling together too, but much more loosely. The particles roll over each other and fit whatever space they're in. And there's a third state of matter. One where the particles are very far apart. What is that state of matter called? Gas. Excellent. Yes, gases. Gas particles move freely in all directions. Right now this room is full of all types of gas. You're breathing one of them. What kind of gas are you breathing? Livia. Oxygen, right. And the particles are so small and far apart we cannot see them. But some gases can be seen. Marco, will you blow out this candle? Oh, come on. Oh, you see that gas?
It's smoke.
Smoke is a gas. Look at it spread through the air as the particles move away from each other. The smoke you see is a gas. Bless you. Now remember how we just said that all that matter in the universe follows certain laws? And because of those laws, matter will either be a solid, liquid, or gas. Yesterday we learned about the law of attraction, and that makes some particles need to be close to one another and others stay far apart. Well, that's not the only laws of the universe, Oliver. There are more. Today we need your help to figure out some of the other laws that also affect solids, liquids, and gases. We're going to show you an experiment. Let's see if we can figure out another law of the universe by watching what happens in this experiment. Coming off of this. We looked at an ice cube yesterday, didn't we? What state of matter is an ice cube in? Jolene.
Liquid.
Liquid. When it melts it is, but what state is it in now? It's got a firm shape and form. I can hold it in my hand. Yes, Quinn.
Oh wait. I'm gonna use the.
Okay, Lucas is dripping.
It used to be water, but now it's a
Solid, here we go. So what's gonna happen? Ooh.
Oh, it's melting. Why guys? Sit down. I can see the smoke. I can see the smoke. I can see the gas. I can smell it. Not smoke, it's steam. Steam and steam. Oh. How does that work?
You're gonna talk about that, Marco. See that?
How does that work?
Let's put my coin in. Are there people talking? Let's add another ice cube just for drama.
Why did you put a coin in that? Why did you put a coin in that? It's melting. It's the funny thing. It's not melting. No. The coin is hot now. It can't
Guys, you have to sit down. I put the rows of chairs and rows of sitters and rows of people at the tables for a reason.
Where's the coin? You're gonna see the coin. The coin is still stopped.
3, 2. So what did we notice with our experiment? What happened when we put the solid ice cube into the pan? What happened, Alexi?
It melted and turned into steam.
It melted and turned into steam. Before it turned into steam, though, it turned into something first, didn't it? What was it that it first turned into, Oliver?
Okay, it was a solid, then it turned into a liquid, then it turned into a gas.
Exactly. Now, why do you think that happened? What do you this solid ice cube to change from the solid state to the liquid state and then to the gas state? What did we add to this ice cube? Let's see, Quinn, what do you think?
I forgot.
Lucas. Did you hear that? What did Lucas say?
Heat.
Heat. So, what is another law of the universe? What is something else that can affect states of matter? What do you think? Marco? Well, not just heat, but also, what would happen if we poured this water back inside the ice cube tray and brought it back to the freezer? What would happen to this liquid water again? Yes, Mac?
It would freeze and turn into a solid.
It would freeze and turn into a solid. So not just heat changes the state of matter, but also, what temperature is the freezer? Cold. So when we talk about hot and cold and warm, what are we talking about? What is the force that we're talking about? Alexi. When you are sick, what does the thermometer take? It takes your temperature. So we've just uncovered another law of the universe. Yeah, please, Lay. Temperature, or how hot or cold something is, can tell matter how to behave. So first we had the laws of attraction, and now we have the laws of temperature affecting the states of matter. That's why something like ice melts and goes from solid to liquid and then to gas when you heat them up. But wait a second. And what about this coin? Why didn't it turn into a liquid? Why didn't it melt? Why didn't it evaporate into gas? What do you think, Alice?
Because it was metal and it wasn't water that turned into solid.
Okay, because it was metal. Well, let me tell you something else. The temperature at which a substance will melt, a substance like ice, versus a substance like, what's a coin made out of, everyone? Metal, yeah, is called its melting point. So which do you think has a higher melting point? Ice or metal? Metal. That's right, very good. So, the melting point means that particles stay together even at a high temperature. So the melting point of this coin is higher because the particles stay together even at a high temperature. What if I took this coin? What if I took this coin and put it inside a volcano? And a volcano that would heat it up to 1,000 degrees. What do you think would happen to this metal coin? Alexi.
It would melt.
It would melt, that's right.
But also,
Mm-hmm.
you have to melt coins to make them.
Metal is melted to its liquid state in order to form the coin, because this wasn't always a circle, right? Metal doesn't come out of the earth as a circle. So absolutely, Alexi, that's a good point. We use the melting points of substances in the world, such as metal, to make things for ourselves, right? Okay. Let's review the other laws of the universe affecting matter that we have just uncovered, or the other law. Temperature determines and changes states of matter. Heat really is energy. Heat is a form of energy. And so when energy in the form of heat is added to matter, it makes particles move apart, causing solids to melt. Bless you, causing solids to melt into liquids and liquids to evaporate into gases. That's right. When this heat energy is removed and matter gets colder, the opposite happens. So the particles, when the heat is taken away or when the particles are cooled, come back together and what happens? They turn back into a liquid or then a solid. Particles pack together causing gases to turn into liquids when the cold is added, which is condensation. We saw condensation on the lid of this pan. That's when the gas cooled down as it went up and turned back into a liquid. Can you see the tiny water droplets on this pan? Exactly. So, I have one more question for you. Which direction did the steam evaporating from the heated water in the pan go? Which direction? Everyone can say it. 1, 2, 3. Up. That's right. Why? Because particles that are heated and turn into gases don't only move quickly and move apart, they also move up. That's right. And guess what? Particles that turn back from gas into a liquid or a solid, they cool and will not only move more slowly and move closer together, they will also fall down. So particles that get heated move up, and particles as they cool move down. That's why we have rain and snow and hail, right? It's particles cooling and moving down.
That's never gonna happen here though.
Well, you never know. You never say never. We've seen how much the world and the universe has changed in history, Marley, so you never know. There was still another rule of the universe for matter to follow, and this law is that all things have weight and will settle with the heaviest substances sinking to the bottom and the lightest substances rising up and remaining on top. Let's take a moment now to conduct one more experiment to see how this might happen. In this mason jar, we have some colored water. The water represents the particles that were of medium weight. They weren't the heaviest, but they weren't the lightest either. In this test tube, what do you think this is?
Brown. Honey.
Honey, close. It's also made from sugar.
Syrup.
It's called molasses, but it's a type of syrup, yes. In this test tube, or in this mason jar, we have molasses. What weight of particles do you think this mason jar of liquid represents? The heaviest ones or the lightest ones? Which weight of particles? Right, look, can you compare, see how it moves compared to the water? Okay. And in this mason jar, we have, what do you think this is? Oil, you're right. So, observing with your eyes and seeing how it moves in the container, which weight of particles do you think this mason jar represents, the liquid in this mason jar? The heaviest or the lightest one? Lightest. Okay. So, if you were to pour our heaviest particles into the water, which is the medium weight substance, what do you think will happen? Do you have a hypothesis? Do you have a prediction, Zoe?
It will go down.
You think it will sink based on the law of the universe we just talked about? Let's try. Take it off the tray so you can see. Okay, I couldn't see it from the angle where I was sitting, but now I can see it. Has the molasses, the heavier substance, settled on the bottom? Okay,
I can barely see the colored water.
now we're going to pour our lightest particles in the water. What do you think will happen? Does anyone have another prediction or hypothesis? Elise?
They will go to the top.
They will go to the top. Let's see if this oil will also follow the law of the universe.
It's making green. It's making green. It's making green.
Can you see the layers that happen?
Yeah, looks like the layers of the
What happens if you shake it?
Let me see, Gail. That's a good question. I can't shake it properly because I don't have a lid and I don't want to make a giant mess on the carpet. But I can definitely swirl it. And maybe what I can do after Keho is put this in a container that does have a lid and we can shake it. You've just given us a great idea for another experiment. So thank you for that. But for now, we'll leave it here just to look at. So what is the law that matter must follow that we have just seen in action? What is the law that matter must follow that we've just seen in action right now in our container with the liquids? Alexi.
The heaviest sits on the bottom, and then the not heaviest but not the lightest goes in the middle. Then the oil can float on the top.
Very good, Alexi. Couldn't have put it any better. Matter must settle according to weight, right? How much something weighs. With the heavier elements sinking to the and the lighter elements rising to settle on the of the three states of matter, which do you think is the heaviest? Solids, liquids, or gases? Which do you think is the heaviest? Ali. Which do you think is the lightest? Solids, liquids, or gases? Caitlin. Gases. So now we know about three laws affecting matter: attraction, temperature, and weight. And now we can go back to our story. Earth at the time of its formation was nothing like the Earth we know today. It was so hot. The surface was so hot, it would have just been molten lava. We couldn't have lived there. Nothing could. So not only was it hot, it didn't even have an atmosphere. So there was no air for us to breathe and no protection from the rays of the sun or asteroids from space. So Earth was a huge mass of blazing heat spinning around in a freezing cold universe. Because the Earth was so hot and the space it was floating in was so cold, particles began to do different things. They were probably very confused with all of these rules to follow, and the spinning matter of the Earth began to form a dance, the dance of the particles. Hot particles of the Earth moved around very quickly. They were crazy with heat, so they spread apart and expanded and moved up. But as they rose higher and higher up towards the freezing cold space, they began to cool, and as they cooled, they began to slow down, come together, and sink back right towards the Earth. Well, what do you think would happen to these particles when they sank back towards the blazing hot Earth? What do you think would happen?
They go up.
They would heat up again, and they would start to heat up again, move faster, spread apart, and go
Up.
And as they got higher, they cooled down, and what would happen? Right, they would go down, and then they would get close to the Earth again, and
Up.
Are you guys beginning to see a pattern?
Yeah.
Yes, you are. Governed by the laws of the universe, the particles forming the Earth were moving in a continuous cycle, an incredible dance, up and down, called the dance of the elements. And this happened over and over and over again for millions and millions of years.